Hey everyone, I hope you all are safe and doing good. So in the series of learning C++ programming language, we are discussing functions in C++. In the previous video, we have seen how actually function call works. That stack, function call stack. What is happening behind the scene when you are calling a function. Right, like that creation of activation record, dealing with parameters, pushing that into the stack, that activation record, then pop out that activation record from the stack when termination, dealing with return address, return value and all. Right, and this is basically we call it function call overhead. Right, if you don't remember that thing, let me just brief you that thing with this example. After that we will be discussing inline function in this video. Right, we have this program, basically a small program. Here we are just adding two numbers. Right, this is the function definition, add two parameters a and b, return a plus b, and here we are calling this function add and we are passing parameter 1 and 2. What is happening behind the scene, how this function call works actually? When we are calling this add, this function add, then the control will go here, and in that memory it's like we are dealing with that stack memory only. So one activation record for this. First we have main function, so for this main we have one activation record here, right, that will be pushed in the stack. So here we have sum, and sum is 0, right? After that we are calling this add, so we are calling this add means control will go here. This is function definition. So one activation record for this add would be pushed in this stack frame, in the stack, or this is called as activation record or stack frame. Right, now here we have a and b. So a would be passed as 1 and b would be passed here, that would be like value is 2. Return a plus b, so 1 plus 2, it will return 3. Right, where it will return? Here, and after that it will just simply print sum. So this is kind of overhead, just creating the activation record, pushing that into the stack, dealing with those parameters, like copying this actual parameter to formal parameter and all. Right, after that obviously saving that return address where you want to return, what next instruction is to be executed, that saving that instruction pointer, base address, stack pointer and all. Right, so this is kind of overhead. So if a function is very small, yeah, obviously this function is very small, just addition, and I have only one line, return a plus b. Right, so this function maybe, or sometime we have just display function rather than add we have display, and here I'm just displaying cout. The value of a and b is like whatever value you pass here, 1 and 2, rather than adding. Right, so if a function is very small, then sometimes this function call overhead might be more than the time spent executing the function. Means the time taken to execute this function, or you can say the execution time of this function is less than the function call overhead time. Right, so in this case we can use inline function. Inline function basically expanded inline while calling that function. Means inline function is a function which is expanded inline when it is called. What does that mean? I'll show you that thing also. See, if you want to make this add function inline function, then you just have to add a keyword inline as a prefix. I mean before this return type of the function. While defining this function, just add here a keyword. So inline keyword, then return type, function name, parameters and the function body. But make sure the function should be very small or simple. Right, hardly it contains like 1 or hardly 2 lines maximum. Right. So, and it's not compulsory that compiler will treat this function as inline function. We can just suggest compiler by adding this keyword that please treat my function inline function because it's very small. So here that function call overhead is more rather than the the execution time of this function. But it's completely depends on compiler whether this function would be treated as inline or not. Right. And sometimes even you don't know, even you don't suggest, even you don't write this inline keyword, and the function would be treated as inline function because the compiler optimizations are very sophisticated. Right, so it will treat that function inline even if you haven't written any inline keyword, and sometimes you have written that inline keyword and your function will not be treated as inline function. Right, so see, now we'll discuss the advantages of using inline function, the drawbacks, and when to use inline function. Right, now what is actually happening when you write here that inline keyword at the function call, while you are calling this function here only at compile time only, the whole body of this inline function would be replaced here. The whole body of this inline function gets inserted at the place of inline function call. So I mean this line would be replaced with return a plus b. Here, return a plus b. So 1 plus 2, return a plus b, 1 plus 2 means 3. So the control will not go here and back and all, directly it will give you answer 3. So definitely it would be faster if you use inline function in your program, and the efficiency would be a little bit more, right? But if a function contains loops or static variables or switch or go to, or a function is large, then do not make that function inline function, right? If a function is very simple, contains only one line or hardly 2 lines, that function you can consider as inline function. Because see, if you use more and more inline function, maybe you think that yeah, it is going to save time, right? The efficiency would be more, right? Execution would be faster. So make every function inline function. But if you use more and more inline function, then what happens? Suppose this is inline function add, and I'm calling this function in my program like 10 times or 20 times. Like add 1, 2, add 2, 3, and like this 20 times I'm calling this function, right? So at every function call, this statement or this whole body of the function gets inserted, right? At every function call. Obviously, this is the meaning of inline function, right? So in that case, there would be, that size of that binary executable file would be large, and it may lead to sometime thrashing. Right? Thrashing, I hope you have heard the term like thrashing in memory in operating system, right? It's because of those page fault and swapping. When page fault and swapping is more, then CPU utilization would be less, and this will lead to ultimately thrashing like in operating system or in memory, right? So that is why if you are calling this inline function many times, then this would lead to this problem, right? If you change in this inline function, right, then you have to obviously recompile all the location where you are calling that function, right, to reflect the changes you have done in this inline function, right? So that compile time overhead would be more also. Basically, in large projects and programs, these inline functions would be treated and this inline function would be written in a separate file, those header file or .h file, so that the definition would be visible to every program, right? So let's run this program. So this is a simple program, right? Addition of 2 numbers. If you run this, then simply it will give you 3, the answer, right? But if I want to make this function inline, so just have to add a one keyword here, inline. Let's run this and see, again it will give you 3. Now this time, it would be treated as this body of the function, return a plus b would be replaced here, like add 1 and 2. So it would be replaced like here, return a plus b. So a, b, we know these are 1 and 2. So a plus b would be given as like 3, that is 3. So now I hope you got the idea about inline function, what are inline function, how to use, when not to use inline function, and like advantages of using this function, drawbacks of using inline function, everything about inline function, right? So in the next video, we'll see what are recursive function and what is recursion. So now I'll see you in the next video. Till then, bye. Take care.